All right, so here we're going to go ahead and we're going to be solving our equations, our trig equations, just using basic, simple rules that we know for algebra and combining it with trig functions. So in this very first problem right here, it says that I need to solve this over the interval of 0 to 2 pi, not including 2 pi, but including 0. And so what we would do in this case, if I have sine x is equal to 1/2, in order to go ahead and get the x by itself, I have to take the inverse function to both sides, and that's going to get rid of the sign on the left, and it's going to bring it over to the right. So this is going to end up being inverse sine of 1/2. And then we should know by now that what we have to do is we have to answer the question of this is where sine is equal to 1/2. But normally it used to be that it was always for sine, it was always between negative pi over 2 and pi over 2. Those are our exact values. This is giving me a range of values that I need my x to be within, is between 0 and 2 pi. So it's going around on my unit circle from 0 to 2 pi. It's no longer bounded between negative pi over 2 and pi over 2. So instead, anywhere between 0 and 2 pi, that my x value, if I take the sign of it, it would equal 1/2 would be a valid answer. So in this case, sine happens to be 1/2 at pi over 6. It also is equal to 1/2 at 5 pi over 6. And that's it. If I went beyond that, if I went to 7 pi over 6 or 11 pi over 6, it would be negative 1/2. So that is not a valid answer. And that's the entirety of my answer for this one. Let's look at number 2. So it says I have 4 tangent x plus 4 is equal to 0. So I'm just going to go ahead and subtract 4 from both sides. And so that's going to get me 4 tangent x is equal to negative 4. And then I'm going to go ahead and divide both sides by 4. And that's going to get me the tangent of x is equal to negative 1. Now my next step would be to go ahead and get x by itself. So I'm going to have to take the tangent inverse. So I'm going to set that up as x equals tangent inverse of negative 1. And then I have to answer the question, where does tangent equal negative 1? And it has to be between 0 and 2 pi. So if I think about that, I know that it equals 1 at pi over 4. So over here at 3 pi over 4, it equals negative 1. And also over here at 7 pi over 4, it equals negative 1. So my answers would be 3 pi over 4 and 7 pi over 4. 3 pi over 4 and 7 pi over 4. And that's it. Those are my answers between 0 and 2 pi. All right, this next one, it's got to be between negative pi over 2 and pi over 2. So I found it really helpful to kind of give yourself a visual. So negative pi over 2 would be here. And then I'm going to do another one and do, oh, sorry, that's negative pi. Negative pi over 2 is just half of it. And pi over 2 would be right here. Okay, so I need to find an answer that's going to be between negative pi over 2 and 0, and then from 0 to positive pi over 2 for this one. So again, all I'm going to do is just divide both sides by 4. And that's going to get me cosine x is equal to negative 1. And then I'm going to take the inverse cosine. So I'm going to take inverse cosine, and that's going to go ahead and get me from my x here. It's going to equal, for cosine to equal negative 1, that happens at pi. It only happens at pi. Now, if I look, pi is over here. That doesn't fall within the range that I have here for my interval of negative pi over 2 to pi over 2, does it? It does not. So this one would have no solutions within that determined domain that I've given of negative pi over 2 to pi over 2. It has solutions, just not within those values. All right, let's look at number 4. So on this one right here, it's already solved for me. I don't have to do anything except for take my inverse. So here I'm going to do x equals, and I'm going to do cosecant inverse of -2 root 3 over 3. So let's think about that. Cosecant. Cosecant's the reciprocal of what? It's the reciprocal of sine. So this is no different than if I had x equals sine inverse. But what am I looking at here? I've got to find what this value is if it was sine, and that's going to be the reciprocal of square root 3 over 2. So now I've got negative square root 3 over 2. Okay? So these are equivalent statements right here. So now in order to solve this, I just got to think, okay, when does sine equal negative square root 3 over 2? And that's going to be at pi over 6 would be positive. So then that's going to be, why did I say pi over 6? Pi over 3. Pi over 3, and that's going to be 2 pi over 3. Oh, nope, that's cosine. Sine is negative in my third and fourth quadrants. There we go. That's what I'm looking for, third and fourth quadrants. So that's instead going to be at 4 pi over 3 and 5 pi over 3. Okay. Now, the problem here is 4 pi over 3 and 5 pi over 3 do not fall within that range between negative pi over 2 and pi over 2. So let's look. I need it to be in one of these two values. Well, 5 pi over 3 is over here, but that's not within the range that I have here going counterclockwise from 0, if that makes sense. So instead, what I've got to do is I've got to find what that value would be if I started at 0 and I went clockwise to get there. Well, that would just be negative pi over 3. That would get me right there. 5 pi over 3 is exactly what I've got there. 4 pi over 3 is going to be over here, and that's outside of the values that I can use. And so my only possible solution here would be x equals negative pi over 3. Okay. All right. This one. Now I'm finding all possible solutions. So that means that there's an infinite set of solutions that I'm looking for right here. And so what I'm going to go ahead and do is keep on doing what I've been doing, get my sine by itself. So I'm going to divide both sides by 2. So that's going to get me sine x is equal to 1/2. And then I'm going to take the inverse sine on both sides. And you know what? Just to change it up, we're going to do arc sine. You got to get used to seeing both. We don't know what to expect from College Board, so just go with it. So where does where does sine equal 1/2? And that's at pi over 6 and at 5 pi over 6, right? So if I was to draw this out, I have pi over 6 and I have 5 pi over 6, okay? Those are my two possible solutions. So what I'm going to do here is I'm going to think, okay, so if I've got pi over 6 and I've got 5 pi over 6, I need to add something to that so that I'm going to get another value right there at that same exact location if I go around my circle an infinite number of times. Remember, it's just add whatever your period is. So my period here is just 2 pi k. So that's what I've got, 2 pi k. And that's where k is an integer. So no matter what value I put in there for k, it's going to get me some coterminal angle of here, for example, okay? It's going to be some value of that. All right, now we're going to do number 6. Number 6 here, all I have to do is solve for cotangent, and so I'm going to subtract 8 from both sides, and that gets me cotangent x is equal to 0. And so now I'm going to take my inverse cotangent, and that is, the question is, where is cotangent equal to 0? And if I think about that, that's going to happen at pi over 2 and at 3 pi over 2, right? So let's go ahead and draw that over here. So if I do that, it's going to happen here and here. So if I go ahead and take that pi over 2, what's the period of cotangent? It's pi, right? So I'm going to do pi over 2 plus pi k. That's what my period is here, and that's going to get me my next one if it repeats, right? Well, if I do 3 pi over 2 plus pi k, these two are going to constantly get me the same thing, because if I just add 1 pi to pi over 2, it gets me 3 pi over 2. If I add 3 pi over 2 and I add another pi to it, that's going to get me 5 pi over 2, which is coterminal with pi over 2. So I don't actually need to do the second equation. It's just always going to get me the value that I need right there. So this would be what you would have. Sorry. When k is an integer. Okay? That is not how you do that. Okay. K is an integer. Okay? All right. Let's look here at number 7. This one's going to be a little bit more of a challenge, and actually looking at the time that I have left to record here before it cuts me off, I'm going to go ahead and make this go into part 2 of my video.